All right, guys, section 10.7, polar coordinates. My little spiel slash rant that, oh, I thought you were going there, Maya. The build-up was there, yeah. All right, anyway, the polar coordinates and the polar graphing, what we're going to call the polar curves that we're going to be getting into section 10.8. This is all new stuff, brand new stuff. We've never seen this before. Hopefully, when you hear me say that we don't have a sense of panic or fear that comes over it. Again, hopefully, maybe you're. Now, I'm using this in math terms, but I was going to say, hopefully you're a little excited about it, because how often do we actually get to see something that is completely brand new? Again, even with the conic sections, yeah, I guess an ellipse was new or a hyperbola was new, but we've done aspects of virtually all of those things. We talked about circles and parabolas already, but again, polar graphing and polar coordinates, this is going to be a new way of looking at things for sure. Again, hopefully you've taken notice to the fact that I very intentionally have not said that it's going to be difficult or hard or anything like that. It's new. It's just different. That's all that we have. All right, so here's the big question. This is the essential question that we have moving forward. How do you describe the position of a point in a plane using distance and angle rather than x and y coordinates? That's the big whole why this stuff exists. So what I mean by that, how can you describe the location of a point? So if I were to plot a point, I'm going to do this on the screen here actually. If I were to go back, yeah, I'm just going to eyeball it here. All right. Does everybody agree that if I went over 4 and up 3, I could plot a point and call it 4, 3? I don't know how many thousands of times you've done this throughout the last 4 or 5 years in math classes, but do we all feel extremely confident if I were to give you a sheet of graph paper or to give you a coordinate plane and say, all right, I need you to take out your pencil and plot a point at 4, 3. Do we all know exactly what that means and where to go, right? We're literally moving horizontally from the origin. I'm moving over 4. Vertically, then I'm moving up 3. Okay? Again, you've done this a million times. So what if, now again, if time were, something that we had an unlimited amount of, I think that we could do this more of an investigative, or with a more of an investigative approach. But what if the direction was, okay, here's a point, describe to somebody who's not looking at it, describe to them where it's located. Oh, and you can't say horizontally 4 and vertically 3. You just can't use that. You just can't say that. You can't talk about horizontal distance or vertical distance from the origin. What's another way that we could talk about this? What do you think, Ben?
I would say distance is from the origin.
Yeah. So luckily, you're probably realizing that I very intentionally chose 4 and 3, because now we can very quickly and easily understand that, yeah, that point is 5 units away, whatever a unit is, it's 5 units away from the origin. But is that if I were to say this point is 5 units away from the origin, do we know that it's exactly there in the first quadrant? There's like an infinite number of points that we could draw that are 5 units away from the origin. And if we start plotting enough of them, pretty soon it's going to start to look like a circle, isn't it? Centered at the origin. Okay? You guys see where I'm kind of going with this? I like where Ben was at, though. What if Ben said, yeah, just from the origin, go 5 units away? Well, wouldn't that go here? Well, now, could I rotate some amount? Again, if we're talking about terrible circle, but if we're talking about some circle, couldn't we rotate some amount until we got, oh, yep, we got there? Or maybe, okay, I actually wanted to not do that. Wanted to rotate more, so I went out 5, and maybe I'm going to go this direction. Maybe that's where I'm going to be. I'm going to end up there. But it all starts with how far away from the origin are we? I went out this much. We're going to call that R. Why do you suppose we're going to call that R? Because that's the radius of this fake circle, this made-up circle that we just created. We're going to throw in a whole bunch of new terms and new concepts and ideas today. Again, because we're getting into a totally different graphing system, the polar graphing system. But that's what it is all predicated on, is that we're going to go some distance away from, we're not even going to call that the origin anymore. We're going to call that the pole. We're going to go a distance away from the pole, and then I'm just going to rotate some specific angle, some amount. Okay? So to get back to there, with this question, how do you describe the position of a point in a plane using distance and angle rather than x and y coordinates? Again, we're not necessarily saying that we went over 4 up 3, but instead we went over 5, or we went out 5, whatever that was, and then I rotated 53 degrees or something like that. Does that make sense? We're still talking about plotting points. We're still talking about identifying location and things like that, but we're getting there in a much different fashion. Okay? So, and I'm sorry, I know that I'm just going to read this off the screen to you. I hate doing that, but this is kind of the way that we want you to think through it. So what we're going to do, we're going to learn how to answer this question by studying, we call them polar coordinates, and the conversion of points and equations from rectangular to polar and polar back to rectangular. So here's the deal. If we were to think about where we started on this little explanation, we said, yep, we're at 4, 3. What I sketched up here, that's what we refer to as the rectangular coordinate plane. Okay? That's the rectangular system. X and Y axis, that's the rectangular. Now, today we're getting into what we call the polar system, the polar graphing system. All right? So, again, that's kind of big picture where we're at. That's what we've got going here. All right? So, excuse me. All right, so here's where we want to start, is with this idea, this notion that within the rectangular coordinate system, basically this is what we already know about. This is what you've been using for years. If you have a point, it's in XY form. Okay, a point's going to be XY. That means that from the origin, you are X units, that's going to tell you horizontally. You are Y units, that's going to tell you vertically. But everything is from the origin, how far did I go, which direction, all that good stuff, right? X, again, is the horizontal distance, Y is the vertical distance. I don't think we need to harp on this much more. You've proven time and time again that you know how to graph in the rectangular system. That's, again, what you've been using for a long, long time. The new stuff now is the polar coordinate system. Now, if you have a point that's in the polar coordinate system, we still have parentheses, value, comma, value, close the parentheses, but now it's not X and Y, it's R and theta. So everything's going to be R, comma, theta. R, if you think of R as the radius, you're going to be fine. It's technically not the radius because technically that circle isn't there. Okay? So what we have to do is, like I said, within the polar coordinate system, if there's going to be anything that's challenging or difficult initially, it's learning all these new words and, okay, here are the new words, but how do they relate back to what I already know? That's what we're trying to do. So R is what we call the directed distance from the pole. Okay, well, what the heck is the pole? So here's the deal. If we have this system, we've forever have been calling this the origin. In the polar coordinate system, that's called the pole. Okay? This piece right here, in the rectangular system, that's what we've called the positive x-axis. This is now what we're going to call, in the polar system, that's what we call the polar axis. All right, so what we're referring to as R, that is the distance away from the pole, aka the origin, right? It's that directed distance. Theta, we've been using theta for angles all year, so again, hopefully it comes as no surprise that theta is again going to be an angle, but it's what we call a directed angle. It's going to go counterclockwise from the polar axis. Just like we always do, we're going to go that counterclockwise. We're going to go out some amount, and then we're going to rotate the particular angle theta, whatever it's going to be. All right? So this is a little bit more, I don't know, in tune with what we're trying to talk about here. If we have the directed angle theta, the directed distance r, we can put that together and say, yep, this particular point, like I said before, oh, it's at r comma theta, or it's, oh, we went out 5 and then we rotated 53.3 degrees or something like that. Okay? Question so far? All right, let's go ahead and try a couple of these. All right, so the first one, we want to plot the point at 2 comma pi over 6. All right, so we're going to do this in blue, we're going to label this point A. So I understand that some of these polar graphing systems, so by the way, the first thing that you are probably noticing as we're about to graph one of these is that within the rectangular coordinate system, probably never thought about it much because we usually called it just the XY plane and stuff like that. But it is referred to as the rectangular system because everything's based on rectangles. The polar system, I don't see many rectangles up there. We see everything seems to be based on circles, right? We're talking now about circular motion. And that's exactly where we're at. So we have the pole and we have the polar axis. So on the polar axis, again, we are 1 unit away, or 2 units away, 3 units away, 4 units away, 5 units away, 6 units away. This is infinite. We could go as far out away from the polar axis as we could possibly want. What we're saying that we're supposed to do here in this first example, we're looking at 2, pi over 6. So from the pole, if I went out 1, 2, we agree that we can put that point right there. But that's not our final answer because that's at 2, 0. That means that I went out 2, but what was my angle? Where I put that point currently, I didn't rotate at all, not yet. So this is at 2, 0 for the moment. We have to rotate until we get to pi over 6. Now, it's not quite the same as your unit circles, not exactly anyway. We have more of a breakdown. Each of these little markings, it's going to be in 15-degree increments, or pi over 12 increments. So the ones that we really recognize, hopefully, are pi over 6, pi over 4, pi over 3, pi over 2. When I say that we recognize these, we recognize them from the unit circle, right? That's not to say that we don't have others. Like this guy here is pi over 12. This one here would be like 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. This is 5 pi over 12. I know that we're making a giant mess, but we need to understand the increments. Now, if we could figure out the radians, the degrees should be pretty easy, right? As long as we know that we're broken into 15-degree increments, right? So like 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75, 90, like that. Okay? So what we've done currently, just kind of go back and recap, is that from the pole, we moved out 2 units. R was 2, so we moved out to the right 2. Now, do we agree that this circle that I'm highlighting here, as long as I put my point somewhere on that circle, anywhere on that circle, R is going to be 2? But there's only going to be one specific spot to where R is 2, and I've rotated pi over 6, and that's going to be right there. No, it isn't. Sure. Elbow hit the thing. All right. Everybody understanding and seeing how we got to this point, that location. From the pole, we went out 2. We rotated pi over 6. Could I get like a thumbs up or a thumbs down? Again, to me, in my mind, this is super easy. We got this. But this isn't the first day that I've seen this. This is the first day that you've seen this. So again, it's learned this a long time ago. It doesn't matter how well, how well I understand this. That's not what this is about. It's how well can we get you to understand this as quickly as possible. All right? So are we feeling decently good about this? All right. Now, let me get rid of this for a minute. All right, so we said that we were going to label this also as A. There's one A. So next up, we're going to plot the point 3, negative pi over 3. All right, so that's going to change things for us just slightly. Not initially. We're still going to start by, from the pole, I'm going to go out now 1, 2, 3. We know that's not our final destination. But we always rotate counterclockwise until what? Until we have a negative angle. Now I'm not going to go counterclockwise, I'm going to go clockwise. So where is pi over 3? It's going to be located 3 units out. It's going to be located there. All right, so that's one option. We just did it that way twice. But guys, don't we have another way of going about this? Could we have gone basically in reverse order? Could we have looked at this and said, all right, my angle is negative pi over 3. I've got to find that line. One of these lines represents negative pi over 3. And as soon as we recognize, yep, there it is, that's the line that is negative pi over 3, could we just now count out 1, 2,